number of planets were moving in the same orbit. The early Earth collided with a smaller Mars-sized planet. Giant impact. Debris from this impact eventually came to form our moon. The Earth-Moon system as we know it today was in place. The formation of atmosphere and ocean. Water vapor in the atmosphere produced rain, forming an ocean. The atmospheric pressure gradually decreased. The carbon dioxide-rich atmosphere transitioned into a CO2 ocean covering the water ocean. Carbon dioxide also combined with rock components and was transported to the bottom of the ocean through weathering and erosion. At this time, the ocean was still toxic with a high salinity and an overabundance of metals. It was too toxic to support life. The early Earth when the atmosphere prevented sunlight from reaching the surface. Primitive life was about to emerge underground in the cave of a geyser. Uranium ore emitted large amounts of radiation, creating a diverse range of materials and eventually producing the early building blocks of life. Water boiled and rose up to the surface, and the surface water flowed back down into the natural nuclear reactor. The temperature of the geyser water remained below 100 degrees, protecting the newly formed biomolecules. The underground environment was reductive, while the surface environment oxidizing these conditions were necessary to synthesize biomolecules. In the Earth's Hadean eon, tidal forces were much more pronounced than they are today. Even lakes had significant urban flow of water, creating wet and dry cycles. These wet and dry cycles were one of the most crucial factors in producing the building blocks of life. Fatty acids came together, encasing the proto-life molecules. Polymerization progressed under the wet and dry cycles. Eventually, protein-like basic materials that could act as catalysts were produced. These molecules circulated between the geyser cave and the surface environment. The interactions of these materials led to more complex biomolecules. Proto-RNA combined with enzymes like basic materials and evolved into ribosomes, which had the ability to replicate themselves. This laid the groundwork for life to reproduce. Finally, these molecules were enclosed within lipid membranes, forming primitive protocellular life. The birth of first proto-life. This was the beginning of life.